So it'll be what? Flip it. So it'll be the 1 will be on the top. And then I say the exponents become positive, so it'll be a to the n now. Right, so that's another rule. So here, from here to here, it will be what? 1 over x to the first. Well, we don't write x to the first, we just write x. So that's another way. For this class, I want you to use the blue way. Do you remember that rule? Sort of?
Yeah, you talked about it a couple weeks ago.
Yeah, I did talk about it. But do you remember from the class that you took? If you don't, that's fine. A lot of time people forget about like math formula. I don't remember much, but this is too basic. Okay, so that being said, go to the radical expression. Is expressed like this. It's n root of a to the m, where n is called the index. Let me highlight it here. So this n right here, oh, it's so difficult. This n right here is called the index. It could be square root, it could be cube root, it could be 4 root, right? The a is called the whatever under the square root, the whole thing a to the m is called the radicand. So let me do like this. That's the radicand. And the m is the exponents, of course. By the way, the radicand is the whole thing, a to the m. Okay, whatever under the square root, that's your radicand. And inside the radicand, there's the exponent m. We're gonna have another note. N root of a, all of that, parenthesis to the m, is the same thing as this. Okay, so it's the same thing as n root of a to the m. Okay, they're the same thing. It's like, don't write this down. It's like 1 over x squared is the same thing as what 1 over x all of that square, right? Do you agree with me? Yeah, the 1 square is 1, x square is x squared. Okay, now another note about this is that the n root of a is considered simplified. Let's consider simplify if there is no perfect square factor, no perfect square factor. I'll tell you what that means, factor in A. Let me highlight what I just said. No perfect square factor. What does that mean? What is a perfect square factor? Don't write this down. What's the square root of 4? 2, right? So that is 4 is a perfect square factor, right? Because I can make it into a nice integer when I take off the root. However, if you, so for example, example of those will be like square root of what? Square root of 2, right? Because square root of 1 is 1. That's integer. Square root of 2 is, you plug in your calculator, it's 1.4 something, right? Square root of 3, so square root of 5, etc. Yeah, so something that you cannot take square root. So it's not a perfect square factor. 4, however, is a perfect square factor. Okay. All right. So far, so good. So those are just basic information you should know. When I say radicand, you should know what I meant. When I say index, you should know what I meant. Right? Product properties. So here there's a bunch of properties of the radical expression. So the first one will be the product properties. Products, when you say product, means multiplication, right? If I have n root of a times b, the radicand will be a and b, a times b. I can split it apart. It's the n root of a times n root of b. So for example, if I have n square root of 5 times 2. By the way, what is the index in this case? What's the index here? What is the index and square root? No, index, the index. Remember, index is the number, the little tiny little number square. So when I say square, what number you represent square? 2, right? 2. So because square root is so popular, we don't write it there, right? It's kind of like x. We don't write 1 times x, right? We just say x. So same thing with square root. We don't write the 2 there, but you should know that there's an invisible 2 there, right? So according to this product property, I can split it apart. Equal square root of 5 times square root of 2. Can I simplify square root of 5 and square root of 2 separately? No, right? Because they are what they are. What they are, the one I highlight in yellow? Yeah, not perfect square factor. Right? It's not like 4 or 16, right? Or 36. So leave it alone. Unless you want an approximation, you can put in a calculator. But at this point, I want the exact answer, so leave it alone. Number 2, you gotta do number 2 for me. Yay. You got the time right, Corey. Are you still in Lake House?
Yeah, I'm coming home tomorrow, but yeah, I got the time zones right this time.
Wow, good for you. I'm jealous. I'm jealous.
I was thinking it was 10, not 8.
Oh, it happens. Okay. What you guys got? What do you have? What do you have? Anyone? Mm-hmm. The cube root of 9. Go ahead. Hey, yeah. Mm-hmm. Can you simplify 9? The cube root of 9. Careful.
3 times 3 is 9. But that-
Yeah, because the cube root, in order to simplify the cube root, you have how many 3's? 3 3's, right? You only have 2 3's. I know it's a very common mistake. Or like, oh, the 3 and the 9, 9 divided by 3 is 3, right? But it's not that way. You need a 3. So basically, this is another property, but I'm gonna give you a little preview first. Whatever index here, and the exponents, in order to simplify the index and the exponent has to be the same, or at least the exponents have to be divided into the index, right? So for example, don't write this down. For example, I have what? 4 root of 2 to the 4. Well, this one divided by this one, so what? Just 2, right? Square root of 2 to the 6. What do you think? There's an invisible 2 here. We don't write, right? 6 divided by 2 is 3, so 2 is just a third. Right? Of course, you have to keep your base. Don't get rid of the base. Say 3 is wrong. So that's a preview of another property, but we'll come back to it. Very good. So nothing I can simplify. I'll leave it alone. Number 3 and number 4 is the opposite. Remember, this is the equal side. So that means the right hand side equal the left hand side. And if I give you the left hand side, you can do the same. You can convert back to the, I'm sorry, if I give you the right hand side, you can convert back to the left hand side, right? So if I give you square root of 5 times square root of 2, I can combine them using that property. Will be what? Everybody under 1 square root, which is 5 times 2. I hope nobody leave it like that. What's 5 times 2? 10. So basically the number 3 and number 4, you go from right to left. 1 and 2, you go left to right. Why don't you do number 4? People from Zoom, you can put your answer in the chat if you want. Anyone? What you guys got? Mike, you have something?
Cube root, like 101.
101? 101. Okay, so you bring it. So first, yeah. I think you got messed up a little bit. You got messed up a little with the yeah. Yeah, 9 times 11 is 99. Thank you, Devin. Thank you, Alex. But that's okay. Thank you, all of you. I think you multiply and then add at the same time.
Yeah, I don't know what I was thinking.
That's okay. It's only 9 o'clock in the morning. And you don't have your coffee. All right. So far so good. That's product properties. Pretty simple. Now, on the exam, you're gonna see this within a bigger problem, right? The reason I'm teaching you this because it's gonna build up. You're gonna have a more complicated problem, but as long as you know these rules by heart, you should be fine. All right. Now simplify. You probably have something like this on the exam. Simplify this. So I'll do the first one. I have square root of 45. Remember the little remark that I did in blue here. N root of A is considered simplified if there is no perfect square factor, right? Now, so this number 45 right here, can you think of two numbers? One of them is going to be a perfect square when you multiply them together. 45 is the same thing as, maybe I'll do slow. 45, I can break it up into what? Yeah, 5 times 9, right?
Sorry,
Yeah, that's okay. 5 times 9, and I can break up into the 9 into 3 times 3, right? So I see what, which is 3 square, right? So I see a perfect square root right there, right? So that means this one right here, I can rewrite it as square root of 9 times square root of 5. Why do I do this? Because the square root of 9 consider a perfect square root, right? I just say called perfect roots because later you have cube root and all whatnot. So for these kind of problems, if I want you to simplify a number, I want you to break into two parts. One of them is you'll be able to take a square root. The other one you won't be able to, right? Square root of 9 is 3 times, while square root of 5 is not perfect square root, right there. So we just leave it alone. Please do not approximate. Why? Because you lose the accuracy. I'm gonna write my square root nicer. Square root. Same thing with 72. I want you to break it up into two numbers that multiply, give you 72. One of them has going to be square root. 9 and 8. Better. But by the way, there's a little trick right here. When you see even number, divide by 2 first. Your first thing is divided by 2. 72 divided by 2 is what's equal? 7,
36.
36, right? Ooh, 36 is, yeah, 6 times 6, which is 6 squared. So you stop it right there. It's like, oh, I have one of them is 36. And one of them is 2, right? So square root of 36 is 6. So square root of 2 is just 2. You try 500. People from Zoom, do you have the answer? Put in the chat for me.
Do you have to put the times before the square root of 2, or can you just do 6 square root of 2?
You don't have to. You don't have to.
Okay, all right, thank you.
Thank you, Corey. I just put it there so people are not confused. Yeah, they don't know what is happening. What is the relationship between 6 and square root 2? Oh, got my glasses on my head still. You do like I did, that little tree back up there. You get even number, I would suggest. Well, you do better, right? I see yeah, 5 and 100. Devin. Thank you, Devin. I think that's right. Okay, so now, if you don't see, so a lot of people they good with like a calculation in their head. The 500 they can see right away, which is 5 times 100, right? Well, 100 is 10 square. 10 times 10 square, right? So you can stop right there. If you don't see it, what happens? Say if you don't see it. If I don't see the 5 times 100, I divide it by 2 because that is even number, which is 2 times 250, right? Double 250 is 500. Divided, continue divided by 2. What do you have? Huh? 1. 125. And can I split the 125? Divided by 5, right? I would divide by 5. So 5 times 12 times 30 by 5 is 2, 25 by 5 is 25, right? And then 5 times 5 again. So how many 5 I have here? How many 5? 3 5. But I only need what? I only need what? 2 5 because the index is 2, right? Or something that can divide it into the index 2. So I only need 5. So actually I'm gonna rewrite it here. I'm gonna have I have 3 5. Let me highlight it. I have 3 5 and I have 2 2. So 2 times 2 times 5 times 5 times 5. Which one have the square? Yeah, 2 square and then the 5 square. And then the 5 here. It should be blue. Well, and then you put the square root over. Well, square root of 2 square is 2, right? Square root of 5 is 5. And so, I'm sorry, square root of 5 square is 5, and the square root of 5 is 5. Nothing changed. Yeah, 2 times 5 is 10. Two times 5 is 10. So 10 times the square root of 5. If you don't see 5 times 100 right away, so you got a long way, right? It's not wrong, it's just wrong. But it makes sure you make sure you got it right, right? But But we see 5 times. So I see 100 times square root of 5. You know what? Let me do one more step. Square root of 100 times 5. And then I'm going to use this property just to break it apart, right? I forgot to do that in the previous problem. So I have square root of 100 times square root of 5. Square root of 100 is 10. And then square root of 5 is square root of 5. So far, so good. 228. We can use your calculator. I'm going to use calculator. Clear that. 28. I'm sorry, 288, not 228. Divided by 2. First thing first, I divide by 2 because I don't see anything. Ooh, I see 144. Do you guys know what number square gives you 144? 12, right? 12. So I'm done, right? 2 times 12 squared, so I'm done. For the sake of the note, I'm going to rewrite it here. So 2 and 144, which is 12 square. Oh, I give you the square root of perfect square table here. So as you can see, 140, 12, where's 12? Right here. So square root of 144 is 12. Right, so you can look it up when you do your homework. I'll give you this on your exam. You will have the table on your exam too. Okay. But I do prefer you to remember it. And a lot of professors, they don't. So it's equal to what? 144 times 2. You say 2 times 144 doesn't matter. And then you can break it apart. So square root of 144 times the square root of 2. Square root of 144 is 12. You try number 5. Remember, number 5 is a cube root. When I see odd number, I divide it by 3 or 5. See, wow, we have one answer already. Oh no, that was the old one. Thank you, Alex. Okay. Do you divide it by 5? Right? And because it's a cube root, you need at least what the least exponents? 3, right? That's the least. It could be 3, 6. Why? Because 6 divided by 3. Not 5, not 4, because 4 and 5 does not divide into 3. So either at least 3, right? 3, 6, 9, 12, etc. So 625, I break it into a bunch of 5 here. So I got 4 of the 5, but I only need 3, right? Because 4 does not divide into index 3 here. So it's the same thing as 5 to the third times 5 to the first. Do you agree? Do you agree? So what's 5 to the third equal? 125, right? So 125 times 5. Or you can say 5 to the third times 5, doesn't matter. You break it apart, 125 and 5 here. 120, I'm sorry, I had to write cube root, I forgot. You should too, because it's no longer square root. You should you need to put the index there. Cube root of 125 is 5 times cube root of 5. Now you ask me like, how do I check my answer? How did you check your answer? I mean, you won't be able to exactly pinpoint your answer because unless you are good at programming, but I'm not allowed you to use computer. So you use calculator, but how do you check your answer? Like you gotta write. You can check, right? Let's see. Cube root of, everybody knows square root, so I'm not going to show you square root, but I'm going to show you how to do the cube root. So you go to math. You guys see math? Math there on the left. 4 button down. Math. And then you have cube root on number 4 there, right? So hit number 4, or you can go down. Enter. Is it 625? Taylor? Is it 625?
Yeah.
Okay, 625 is roughly 8.5498 something. Now your answer is 5 times. Again, I want cube root, so go to cube root, go to math, and then go down number 4. Cube root of 5. Is something wrong? Something wrong. Hang on, 5 times math. Oh, why is it error? Here, 5. You should be able to 5 and then do. I don't have to do the multiplication. There you go. So I just have to put the answer. So it's the same, right? Does that mean you got the right answer? Okay. The second one is, if I have a square root of something square. Now, before that, I give you the example. You say, so don't write this down. Square root of 4 is, you say 2, right? Square root of 9 is 3. Square root of 36 is 6. The reason you don't need the absolute value because you know these are positive. But what if I give you a letter? Square root of x squared. Well, x can be negative or positive. Why? Because when x is negative, I square it become positive, right? If say x is negative 2, then square root of negative 2 what? Square is square root of 4, which is 2, right? But it's not right because 2 is not right because x is supposed to be negative 2. So what you're gonna do is you're gonna put the if you give a letter, you're gonna put the absolute value around it. So that means this equal to absolute value of what? Of x. Because why? Because absolute value of x can be either, yeah, positive x or negative x. Right? So for this guy right here, I'm gonna put an absolute value around negative 2. Right? The reason I'm doing this because so the even root, like square root, 4 root, 6 root, they don't like negative number. You cannot have negative number under the square root. If you don't believe me, you can check with your calculator. Say square root of negative 4. Where's my negative? Delete negative 4. It's a non-real answer, right? For now, we're gonna say non because not a real number. Later, we're gonna learn about complex, which is imaginary number. We're gonna learn about the negative square root, but right now, it's not a real number, right? It's not in the world that we know. So just remember, if you have square root of x squared, and you take off these, so you cancel the square root and the index. I don't know you see, but the index here will be what? 2, right? 2. Of course, the 2 and the 2 here cancel. 2 divided by 2 is 1. So to the first right there, which we don't write. But it's the odd exponent, right? Okay, so let's go. Let's do some example. I don't know why I leave the space for, I forgot. Oh, I think the space for this. Yeah, that's a space. Okay, so example one. If I was you, I'm gonna break apart the 16 and an x squared because they are two different things, right? 16 is a number, x squared is a letter, so I'm gonna break it apart using the what rule here? What rule we just learned? Product rule, right? Product. So I can break it apart into square root of 16 times square root of x squared. What's square root of 16? 4, right? You don't have to do absolute value of 4 because you know 16 is 16. Is right on your eye. There's no hiding. But the x squared is the variable, the one that you don't know. So square root of x squared will be absolute value of x. Multiplication if you want to. What about number 2? Now, I hope nobody doing this. Maybe you want to write this down. It is not true. It is not true, right? If you don't believe me, you take square root of 5 plus 2. It is not equal to square root of 5 plus square root of 2. You can use a calculator to verify that. I'm not doing this. So it's wrong. So, well, if you stuck, try to factor. It's three is by trinomial. So can someone factor this for me? People from Zoom, you can speak it up if you like. Something times 2 number multiply, give me 1. Huh? Yeah, x plus 1, which is x plus 1 squared, right? No, x plus 1, x minus 1. It's going to be x squared minus 1 squared. Yeah. But thank you for checking. Okay, so x plus 1 parentheses square. And again, outside here, there's a index 2, invisible 2. We don't know. Oh, we don't write. So it's equal to what? The 2 here and the 2 here cancel. 2 divided by 2 is 1, right? So it'll be x plus 1 to the first. What do I miss? Absolute value, right? I cannot just leave it like that. Remember, I don't know x is positive or negative. If x is like -3, -3 plus 1 is -2. Negative. We cannot put negative in the square root. X to the 4. X to the 4. X to the 4. I'll break it apart. The x squared times x squared, just square root of x squared times square root of x squared, which is absolute value of x times absolute value of x, right? Which is absolute value of x squared. Now, is it necessary? Is it necessary to put the absolute value around x squared? Is it necessary? It's not wrong. I'm not going to take your point off, but is it necessary?
No, because positive or negative. It's
Yeah, square that number is going to become positive. So you don't need to. No need. Now the bottom line here, the bottom line, the little remark. Where am I? Remark. Are you purple? Not my favorite color, by the way, but it just look pretty on the notes. If I have square root, so if the index is like 2, it doesn't have to be square root. It has to be what? Even root, like 2, 4, 6, etc. Right? 8, 10. Then I'm gonna put a big X here. like a Roman X, just indicate like a big radican. When I take off the square root or the 4 root, if my exponent is odd, then you should put the absolute value around it. If your exponent is odd, right? So for example, number 1 and number 2, your exponent is what? Is odd, right? X to the first, x to the first, x plus 1, all of that to the first right there. But the second one is even, right? So you don't need absolute value. Does that make sense? X to the, if I my answer x to the 4, I don't need that, right? X to the 4, anything to the 4 power be positive. So that's the remark. If you start with even index, you end up with odd exponents, put absolute value around it. Okay. So far, so good. Does anyone have a question? Okay, let's move on because we have a lot to cover. I'm so sorry. This section is just long. All right, part C is we have another property for any real number a, and a is in real number. Then cube root of a to the third is equal to a. Why? Because the cube root is very easy going. If you have a graph of x cubed, it looks like this. What is the domain and what's the range? You should be expert by now. That's x cubed. That's y equal x cubed. What is the domain and range? What the domain first? What's the domain first? From left to right, what do you see? Yeah, all real number. What about the range, the height? Also all real numbers, right? So it's a very easy going function. Y equal x cubed. Now y equal x squared. Don't write this down. It looked like this, right? So the domain is all real numbers, but the range is what? Only positive, right? It stay above the x-axis. That's why we need the absolute value. So for any real number, cube root of a cube is equal to a, or if I extend it into odd index, like 5th root, 7th root, 11th root, right? Is you don't need the absolute value. If you have odd index, that's easy. You don't need to worry about the absolute value. What is the cube root of 125? You should know this. 5, right? I don't need absolute value, first of all, because the number. What about this one? How can I rewrite the 8? I need to turn it into a cube. What number when you cube give you 8? Yeah, 2 times, 2 times, 2 times, 2, 3 times, right? So 2 cube. I can rewrite it as like this. Is that okay? Remember I said something in the beginning? 1 over x squared is the same thing as 1 over x, all of that squared, right? So on the top is 1, doesn't matter. Okay, so the cube and the cube cancel. This and this cancel, so it's equal to, by the way, when I say cancel, what do you take divided by what? You take the exponent divided by the index. One of my mentors called the boot method. You draw a little boot here, you kick it over. So 3 over 3 is 1. And I don't know if it help you to remember it. It's called the boot method. It's kind of cute to me. That's why I remember. But it's not mine. It's his idea. So 1/2, right? Or you can use a rule. Okay, third one. If you see a letter and a number, I suggest you break it apart. So I'm gonna break it into using property, cube root of -27 times cube root of x cubed. Do not forget to write the index. No longer square root. If you don't write the index, people understand it's a square root. What is the cube root of -27? You can use a calculator if you don't know the answer. Does the calculator give you an answer? Yeah, -3, right? I'll tell you, it's cube root, very easy going. It'll take everything, right? So it'll be -3. Let me write it one more step. So -3 cubed times cube root of x cubed. And this is -3. And what's cube root of x cubed? X, right? Do I need absolute value? No, right? Remember cube root? They'll take everything. You forgot, you remind yourself what the domain and range of cube of x to the third. Almost there. We have two more properties. Well, the last two are a little challenging, but two more and then we'll be done. And please do your homework. Don't wait until like Sunday night or something. Do it now while it's fresh. So the fourth property is, again, a is a real number. Then I have n root of a to the m. The same thing as n root of a, all of that to the m. Do you guys remember this? You guys remember this? I wrote this up here, the very first one. Where is it? Right here in green, right? You can move the m outside, doesn't matter, right? Where am I right now? Oh, and then remember the boot method? The boot method. I kick the m over, so m divided by n, that will be your exponent now, right? And then you can get rid of the root, right? The root, the radical, what they call it. Boot method. Right, I don't know how to roll for boot. Okay, so I can convert from radical to expression, what is it called? Radical, rational, no. Exponents, right? I can convert from, so from this step to this step is radical, sorry, to exponent, because no longer root, right? When you have an exponent. All right, so let's see, how do you simplify this? Typo. First, you're gonna split the largest exponents, a number that can divide it into index n. What does that mean? What does that mean? For example, don't write this down. For example, if I have square root of 4, I'm gonna say square root of 8, square root of 8. Then I can split it into what? I can split it into, remember, you can split it into one, you can take out the square root, the other one you cannot, which is, by the way, Zoom people can talk to if you like. We did this. If you forgot, you can do a little tree. Right, so here 2 squares. So I have square root of 4 times 2, right? And then square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 is 2. So that's what they meant by split the largest exponent, a number that can divide. So that means what? Maybe I'll skip a step. Don't write this down. So square root of 4 is the same thing as 2 squared, right? And of course, the square, the index here, I'm sorry, the exponents here is divide into the invisible index here, right? So that's what they meant. I'll give you another example, but please don't write it down. Just listen. 32. So graph 32. It's the same thing as, if you do a little tree again, it's the same thing as 16 times 2. Do you agree? 16 is 2 to the 4. So grab 2 to the 4. What's square of 2 to the 4? Again, there's an invisible 2 there. 4 divided by 2 is 2, which is 2 squared, right? It's 4. Right? That's what they meant. That's what they meant by the first step. What they meant by the first step. So let me erase all that. So you split something, the exponents that be able to divide into the index. That's what they meant. And then you use the rule above to simplify. So let's do this. So square root of m to the 13. I can split into what? I can split into What is the largest number divided into 2? Of course, there's the 2 here. There's a 2 there. What is the one that next to 13, below 13 that divided into 2? 12, right? So m to the 13, I can split it into m to the 12 times m. You want to be careful using m to the first, right? So split one more time, m to the 12 times the square root of m. Well, 12 divided by 2 is 6, right? So m to the 6 times the square root of m. Do I need absolute value around m to the 6? I start out with even index, so I gotta watch out. However, I end up with what? Even exponents are okay. Remember, even exponent, though, all negative or positive, everything turns positive. Remember the remark here? Only if you only you end up with odd when you start with even. Why don't you guys try number 2? Put your answer in the chat if you can. 3 and 5, I want you to do at home. Please do it at home. For those people, for those problems I asked you to do at home, I suggest you do it because that's a good chance I might just take it and put it on the exam. Because I didn't do it. I didn't use it. I gotta use it somehow. Let me see. It's the 5th root now. Anyone got the answer? I know your answer is gonna be a little bit weird, mostly because of the index. What is the largest number next to 7 that divide into 5? Of course, it has to be less than 7 to 5, right? So it'll be u to the 5 times u to the, yeah, it's second. Well, break it apart one more time. If you don't want to do this step, you're good at it, you don't have to do this step. So the first one is u. Do I need absolute value? It's odd index. No, right? Odd index, you're okay. You don't have to worry about much. And then 5th root of u squared. Nothing you can do about it.
Now, can you change that to look like, I know it sounds dumb, but like, well, maybe it does to me anyway, but can you change that instead of like the 5th root or whatever u squared?
Oh, yes, yes,
with
yes.
the 5/2?
You can do like this. You can do u times u to the 5th root of square outside like that, or u times u to the what? Remember the boot method. What do I kick it over? The 2. So 2/5, right? And do not put the radical, right? Because when you change to the boot method, you change into exponent.
Yeah, that's what I was.
Yeah. So either one of them, they both correct. All of 3 of you are correct. But the last one, unless I ask you to, don't do it. Because 3 at home, I don't have time. At home, I gotta do 4. Please do it. Important. Okay, so again, I'm gonna break it apart. Do I have to? Yes. Do I want to break it apart? Do you remember how I break? Remember, let me go back. I don't want to do it. Remember in the very first example, I break the 45 into a perfect root and not perfect root. I'm gonna do the same here. Okay, I'm simplifying anyway. So a perfect root and not perfect root. Okay, so perfect root. 1 by 1, 150. What the 2 number you can break into one of them, you can take a square root. Use your calculator. Don't look at use your calculator. So 150 divided by 2, what you got? Yeah, keep dividing. 150 divided by 275 divided by 5 divided by 5. So I have 2 times 3 times 5 square, right? Use your graph, use your scrap paper. So 2 and 75. 75 divided by 5 is 15. And 15 is 5 times 3, right? How many 5 you have there? 2, so 25. And then 2 times 3 is 6, right? If you want to check, take 25 times 6, 25 times 6, it gives you back what? 150, right? So you are correct. So 25 is the perfect square root, hence I put it on the left. 6 is not, I put it on the right. Next, m to the 9. I want you to split it apart. One of the m gonna be divisible into the index 2. So m to the some power here. And m to the some power here. Remember, the left one is the perfect. What is the largest number that next to 9 that can divide into 2? 8. So m to the 8, right? And how many left? How many do you have left? 1, right? N. How about n? Should be good by now. 2 and 1. Right. So the perfect one you put on the left, the not perfect you put on the right. Square root of 25 is 5. Square root of m to the 8 is m to the 4. Square root of n squared is n. And then because this right one is not perfect, you rewrite it as it is. So square root of m times n. Almost correct. What do I miss? Almost correct. Maybe if this problem is 5 points, I'll give you 4 out of 5. But maybe all that work, you know. Yeah, but one more thing. N. What do I miss in the n? What do I have? Yeah, absolute value. Remember, you start out with even index, right? So you're gonna watch out. If the exponent is odd, in this case it is, right? And to the first, you're gonna put absolute value around it. We do the next one next. I'm not done yet. I'm running out of time. I want to do all of this here. So we'll do it next time, okay? Maybe number 3, number 5 too. But try at home first. All right, so it's faster for me to go over. All right, thank you for staying late again. Have a good one, and I'll see you Wednesday. Okay. Bye, Zoomer. Have a good one. Where are you?
Our exam is this Thursday.
Bye. Huh?
Exam, the next exam is
Oh, the next exam? When's the next exam?
Thursday.
Hang on a second, guy. Don't leave it. Oh, you gotta leave. Monday. We don't have class on Tuesday. Let me double check, okay? Oh, there's a typo here. It's supposed today is 8.2, but I put 8.3 first. So it's supposed to be 8.2. Yeah, exam next Monday already. Okay. Thank you.